In these couple of examples, we just have a couple of special cases of systems of linear inequalities. So with the first one right here, if we take a look at the first condition, it's solved for y alone. And so it really just has a y-intercept at 1 and then a positive slope of 1/2. So because it's just a strict inequality, or it's just a strict greater than, then we're just going to have a dotted or a dashed sort of line. Because that symbol right there is a greater than, then everything that's shaded above the line would satisfy that particular linear inequality. And then the other linear inequality that we have here is basically almost the same thing. It just has a y-intercept though at -1, but still the same positive slope of 1/2. So you can see that these dotted lines are going to run parallel to each other. The inequality symbol that we have there, though, is a less than, so everything that's going to be below that line is going to satisfy that particular inequality. So that graphs ultimately the system, as we're instructed to do right here. But if we were to actually identify what the solution set to the system is in actuality, it really should look kind of more just like that. And I got to keep erasing, I guess. So that's what the solution set looks like. Nothing, right? But if we were to graph the system, ultimately I guess that's what it looks like. But of course there's going to be no solution to the system because there's no point on the coordinate plane there that's going to satisfy both the red condition and the blue condition at the same time. In the other special case, it's almost kind of the same thing. It's just the inequality symbols kind of get flipped around. So we have like the same borders and the lines are still going to be dotted. Just got to get that sketched out right here. And so yeah, the only difference is that because that's a strict less than, every point that's below the red line is going to satisfy the red condition. And then because we've got the strict greater than right there, everything that's above the blue dotted line is going to satisfy the blue condition. And so what we end up getting then is we end up getting, kind of back that up a little bit here. There we go. So we end up getting kind of that middle region that's going to be the solution set because it's going to be where the red and the blue intersect each other. So if you leave it colored as it is, it's pretty clear what the solution set is. As I've alluded to earlier, of course, you could also just shade in just the part that's going to satisfy the entire system, and that would work appropriately as well.